Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, thanks for joining. Please take your attendance in you future. So this is week number 6. Week number 6. We will start with chapter number 2, stiffness method. So it is about 5 weeks. So start from week number 6 until week number 10, yeah. Okay, so under stiffness method, there will be 3 types of structures that we will cover. We will start with truss analysis, and then beam analysis, and then frame analysis. So we will cover these three type of structure, and these 3 type of structure, okay, under the textbook, there are three chapters. Chapter number 14 for truss, chapter number 15 for beam, and chapter number 15 for frame. Okay, so stiffness method ni is new topic. Even though this is new topic, but actually we still deals with the same thing. We will analyze displacement and forces. And for first session, for stiffness method, I will use the textbook to explain about this topic, especially new term. There are new term, a new procedure as well, even though the goal is same. The goal, if flexibility method, we will analyze reaction. Truss analysis also, we will analyze forces. But before forces, we will get the displacement first. Then only we get forces. Okay, so tonight, what I plan is we will read together the textbook, and we will also ask ChatGPT to elaborate more about truss analysis using stiffness method. Okay, for the notes, you can refer to MOOC CES 521. So nanti saya bagi the link for you to join, because dalam MOOC CES 21, so semua ni dah ada, all notes, the PDF notes, the video, the activity, the question have been put into MOOC. Okay, and nanti saya akan tambah lagi lah. Saya akan also add more pages here, okay, to include examples, more examples, slide. There are many slides as also I will put here. And from previous session also, I have actually prepared one new updated slide based on conversation with ChatGPT as well. Okay. So first session ni memang sebab dia new topic, memang tak ada pilihan, you have to listen carefully, because banyak new term yang saya akan introduce, and dia sama macam flexibility method, sebab once you understand the procedure, the fundamental, the term, understanding the truss means you should be able to solve beam and frame. So that's why for the first session, I will start with the fundamental. Tapi kalau flexibility method tu saya start dengan derivation, but for stiffness method saya tak derive the formula. Okay, sebab it is too complicated. Kita pick important point only. Okay, so you have to read books. This is the main reference. So main reference bukan nota slide. Sebab semua nota slide is come from this book. This is one of the famous method in the world. Okay, in structural analysis. Okay, so saya nak together dengan you all tonight untuk kita tengok what is important that is highlighted here under the textbook. Okay, so we start with truss analysis using stiffness method. Okay, kat sini. Okay, dia ada highlight some important point. And important point, all these important points saya nak buka chat GPT untuk dia elaborate. Chat GPT. So that this activity akan also train you all untuk gunakan chat GPT the right way. Okay, elaborate and respond in English. Okay, so this is actually dia describe balik. Okay, the page given. Okay, this is about the stiffness method. Why is it for? The chapter overview. Kita tengok fundamental of stiffness method. Fundamental of stiffness method. So when we learn stiffness method, dia akan ada comparison dengan flexibility method. Because the word itself, flexible versus stiff. Stiff dengan flexible ni dia berlawanan kan, berlawanan. Stiff versus flexible. So that is why dia akan compare. Okay. So dia highlight kat sini, stiffness method is displacement based method, flexibility method, force based method. Okay, yang ni ya, stiffness method, flexibility method. Stiffness method is displacement method, flexibility method is force method. Dia highlight dekat sini. Stiffness method, displacement method, force method, flexibility method. Okay, so because flexibility method, we determine redundant, and redundant is force. Redundant is force, so that's why dia ni dia panggil force method. So kalau stiffness method is also known as displacement method, makna dia displacement is the first output. Displacement is the first output. Force method, flexibility method is the same. Kalau dalam buku teks tak jumpa topik flexibility method, you have to refer to force method. So force method means force is the output. Redundant is force. Redundant is a force. Redundant is reaction and also internal forces, member force, and all these are forces. So it is also called as force method. Stiffness method, displacement method. Stiffness method, displacement method means that the first output that we will get from the analysis is displacement. Okay, ni yang kat sini kita nampak dia dah terus bagi in point form. Stiffness method is displacement based method. Flexibility method is force method. Okay, we look at the advantages of stiffness method. Semua ni yang dalam teks tadi, dalam textbook. Yang mana whenever you letak je dalam chat GPT, okay, then dia akan elaborate more detail. Okay, and lagi tersusun lah. Okay, advantages of the stiffness method. Number one, stiffness method can be used to analyze both statically determinate and indeterminate. But flexibility, we only use flexibility to analyze indeterminate structures. Sebab apa? Sebab bila kita apply flexibility tu maknanya equilibrium equation enough. Only is not enough. Then only we apply flexibility method. But for stiffness method, if we want to analyze determinate, also we can use stiffness. If we want to analyze indeterminate structure, also we can use stiffness method. So this is the first advantage. Okay. Simplify the process compared to. Okay, number two, point number two. Point number two, under advantages, point number two, simplifies the process compared to the flexibility method, which require distinct procedure for different structural cases. This is actually, the stiffness method ni is theory behind software. I believe you have been used. You use esteem. You use esteem during diploma project. Okay, esteem tu structure software, right? So actually the theory behind software is stiffness method. So step-step yang kita akan buat to solve the structure using stiffness method adalah step yang sama yang kalau kita nak modelkan building guna software, we follow the same step. We follow the same step. Okay, so dia punya prosedur dia lagi nampak uh, better than flexibility lah. Better tersusun sebab dia pakai formula. Dan dia lagi simple. Formula dia formula matrix dan solution dia is very simple. After you understand the concept, the fundamental. So fundamental is very important sebab walaupun formula dia matrix formula, solution dia solution matematik biasa, matrix multiplication, but still fundamental is very important. Okay, and point number 3, under number 2 tu, under advantages, point number 3, cuba tengok point number 3, directly provides displacement and internal forces. Means that if we refer back to flexibility method, we only use flexibility method to calculate reaction and internal forces. We cannot get displacement by using flexibility method. Using flexibility method, we cannot get displacement. We only get redundant. Redundant is forces. We only get forces using flexibility method. So bila nak calculate displacement guna flexibility method, we have to add another method which is called as unit load method. But for stiffness method, we will get the displacement and the internal forces directly. So ada dekat sini. Okay, stiffness method yield displacement and forces directly. Analyze statically determinate and indeterminate structures, and stiffness method yield displacement and forces directly. They compare dengan flexibility method, displacement cannot. Displacement are not obtained directly. Okay, and generally much easier to formulate the necessary matrices for the computer operation. Okay, so all structural engineering software, maybe ETABS, maybe LUSAS, SAP, and many more. So semua tu pakai stiffness method, McWay satu lagi. Okay, banyak software yang sebenarnya semua tu adalah stiffness method. So the theory behind the software is actually the stiffness method. Okay, so the stiffness method is favored for its ease of generating the necessary matrices. So stiffness method ni, semua matrix, semuanya in matrix. So formula tu is given. So we will solve matrix, multiplication matrix. So formula of stiffness in matrix. Nanti we will get the force displacement equation also in matrix. So semua in matrix. Sampai kita calculate D pun using matrix. Kita calculate Q also in matrix. Okay, the stiffness method reliance on displacement as the primary variable. Okay, yang ni yang kita akan dapat dulu, the primary variable, and it more adaptable for various structural conditions. Okay, its compatibility with computer algorithm position and as a modern tool for engineers handling complex system. Okay, so kalau untuk manual calculation, memang dia akan ada limitation so that we can solve it manually. So whenever the unknown displacement is more than 3, so then at that time we cannot calculate using manual calculation, then we can use software, we can use programming, we can use software to solve for the displacement, for the unknown. Okay, the approach simplifies analysis by streamlining the matrix formulation, thereby reducing manual effort and errors. Okay, so kita go back to this. Okay, kat sini ada one important term, which is this, ya. Application of stiffness method requires subdividing structure into element and identifying their endpoint as node. Kita nak minta dia explain sekarang ni, what does this mean? About subdividing structure into element. Okay, dalam textbook tu dia mention about subdividing structure into element. So we have to understand that statement. Okay, subdividing structure into element. This process involves breaking down a complex structure into smaller, more manageable pieces called finite element. It is crucial step in method like stiffness method, okay, as it allows for the precise analysis of each component behavior and interaction. Finite element and nodes. Finite element, these represent the individual structural components such as truss, members, beam or frame segment. Node is the endpoint of this finite element, representing joint or key connection point in the structure, whereas force and displacement are analyzed. And then kat sini dia highlight also about the force displacement properties. Force displacement properties. Okay, nanti saya explain what is force displacement properties. We will solve actually the displacement and forces using force displacement equation, and it is also known as stiffness equation. Okay, the force displacement relationship, kita tengok dulu apa dia explain, nanti saya elaborate more. Okay, nanti dekat OneNote. Okay, the force displacement relationship of each element are established using equilibrium equation. This equation describe how the forces at nodes. Forces at nodes. Displacement also at nodes. So in stiffness method, semua yang kita akan analyze, semua pada node only. Displacement at nodes, forces at node, semua dekat nodes. Okay, also pada nodes. So we are going to assemble the structure stiffness matrix, which we use the symbol K for stiffness matrix. Stiffness matrix, size of the matrix nanti dia akan depending on degree of freedom. Degree of freedom, nanti saya akan tunjuk what is degree of freedom. Structure stiffness matrix. So this is the key characteristic of stiffness method. And then kita kena assemble dulu structure stiffness matrix. After that kita akan apply the stiffness the stiffness equation or force displacement equation to solve for the unknown displacement. Lepas dapat unknown displacement, then only we will calculate forces. Calculate forces using the same equation. Using the same equation. Okay, kita tengok kat sini apa yang dia explain. Okay, yang saya highlight tadi. Okay, tengok pada keyword ya. The keyword is subdividing the structure into element. Subdividing the structure into element. Maksud dia kalau kita ada one truss, kita ada one truss macam ni. Okay, truss ada pin dekat sini, pin dekat sini. Ada dua pin. Ada dua pin. So sini ada A, B, C for example. Lepas tu katalah ada loading 100 kilonewton. Okay, this is conventional way kita lukis truss. Truss yang ada dua member, this is how we draw. Okay, ada member AB, ada member BC. So yang ni structure. Truss is a structure. Dividing structure into element, maknanya bila kita nak analyze, kita kena pisahkan dia jadi elemen. Pisahkan structure menjadi elemen. Pisahkan. Okay, so kalau ada dua elemen, pisahkan jadi dua elemen lah. Kalau ada 5 elemen, pisahkan jadi 5 elemen. So, itu makna dia subdividing structure into element. Pisahkan jadi elemen. And identifying their endpoint. Identifying endpoint. Sini endpoint, sini endpoint. Identifying their endpoint as node. Identifying endpoint as node. Hujung-hujung tu dia kata identifying endpoint. Identifying their endpoint as node. Okay. So makna je kat sini dia from structure ni turun ke bawah. Structure is actually come from element. Element. And element come from nodes. So this is the flow. So inilah dia flow yang bila kita guna software untuk build one structure. Kita akan start dengan node. What is node? Node is join. What is node? Node ni adalah join. Join A, join B, join C. Itu node. Lepas tu, bila kita nak jadikan elemen, kita kena gabungkan dua node. So that's why bila kita guna software, kita akan start dengan, okay, letak satu node. So kita letak coordinate. For example. And then kita declare lagi another node. 3, 0. Declare another node. So ni jadi dua node. And then kita buat apa? Kita gabungkan. Betul tak? Siapa yang pernah guna software? Kita gabungkan. Gabung ni untuk apa? Gabungan dua nodes ni menjadi elemen. Biasa tak guna any software? Masa projek diploma dulu ada buat kan? Bila nak modelkan structure tu, kita akan start dengan create node, satu point dulu, and point tu akan jadi origin, yang itulah dia 0, 0. And then kita akan from that point, kita akan create another point. So dia ada dia punya coordinate, and then kita akan combine these two node. So combining these two node means that kita jadikan dia element. Maknanya elemen ni adalah terhasil from two nodes. Two nodes element. And then many element, one element consists of two nodes and many element akan membentuk structure. Many element akan membentuk structure. So dia punya flow macam tu. Okay, so maksud subdividing structure into element adalah kita untuk analisis, kita dapat soalan structure. Tapi apa kita kena buat, kita akan pisahkan jadi elemen. Kalau ada dua elemen, kita kena analyze element 1, analyze element 2. Kalau ada 3 elemen, element 1, element 2, element 3. Okay. So kat sini, kalau conventional way, kita draw truss, kita akan draw, okay, ni, kita akan draw just like this. And then kita akan label point. Dia ada join dia kan. So kita akan labelkan satu join kat sini. Ni satu join, pin jointed plane truss. Okay, ada 3 join. So join dalam stiffness method kita sebut sebagai node. N-O-D-E, node. N-O-D-E, node. Okay, and then sebelum ni kita sebut elemen as member. Member AB, member BC. Member AB, the length for member AB is 10 meter, for example. The length for member BC is 5 meter. So, member AB and member BC in stiffness method, kita tak sebut dia as member, but we use element and we use numbering. So semua ni yang ABC ni semua tak pakai in stiffness method because we use numbering. Okay, so kat sini kita tengok lagi apa yang dia explain. For truss analysis, finite element are represented by each of member composed truss. Okay, member dia akan combination of member ni elemen ya, compose jadi truss. Node represent joint. Node represent joint. And then kat sini dia highlight about force displacement properties. Force displacement properties. What is force displacement properties? Force displacement properties ni you dah pernah tengok bentuk dia masa you buat tensile test dalam lab. Properties ni dalam structure dia punya visual dia adalah graph. Visual dia adalah graph lah. Visual dia adalah graph. Balik. Macam mana nak buat dia? Ni. Balik. Sini. Ni. Okay. Okay. So, tensile test you dah pernah buat masa lab dekat lab tu kan? Dekat heavy structure lab tu, you ada buat tensile test kan? Diploma dah pernah buat. Betul tak pernah buat tensile test? Yang mana masa you buat tensile test tu, you akan ni ada rod tu kan? Rod. And then you akan buat apa? You akan tarik this rod sampai dia putus. Okay? So, rod tu represent material lah. Represent material. And then apa jadi? Dia akan ada neck tu. Cantik lah. Dia akan ada neck dekat rod tu. Ada neck. And then what happen after that? Dia akan patah lah. Putus. Saya tak pernah lukis. Okay. So ini tensile test. So bila you all buat this tensile test, kita dapat satu graph. So graph tu bentuk dia lebih kurang macam ni. Lebih kurang macam ni. Okay. And then dalam graph ni we label paksi Y tu, paksi Y as stress, paksi X is strain. Okay, and dekat sini dia ada satu point yang kita panggil dia yield point lah. Graf tak cantik, saya tak nampak sangat lah. So, yield point. Sini yield point. Do you remember this? Do you remember the... Can you recall about this?
Yes.
Okay, lepas tu dekat graf ni, dia ada gradient. And the gradient is E. The gradient is E. What is E? E is modulus of elasticity. Modulus Young. Yang kita, bila kita buat analisis kira displacement kan, kita akan masukkan EA, EI tu. So, inilah dia punya E tu. Okay. So shape ni, this is the relationship between stress and strain. Stress and strain. So, stress and strain ni, this relationship, yang kita akan dapat E sama dengan stress divided by strain. Stress divided by strain. Okay, ni, this is the formula we get. Okay. Ataupun ni sama dengan E. Ni formula dia kan. So, this behavior, this is for material. For material. So, different material akan produce different E. Okay, we actually have another visual just like this, tapi balik je tadi. Okay. Bentuk sama macam ni. Bentuk sama, tapi ini adalah Q. Ini Q. Yang ni displacement. Ataupun F dengan, ataupun pakai F. Ada yang pakai F, ada yang pakai delta. Samalah. sama. Q pun force, F pun force, and D pun displacement, delta also displacement. Okay, so bentuk dua ni sama. Bentuk dua ni sama. Yang atas tu adalah stress-strain relationship. Stress-strain relationship. From that, we get the material, the modulus of elasticity. So, yang inilah yang disebut sebagai material properties yang kita akan jumpa setiap kali kita guna software, dia akan ada part material properties yang kita kena input. Okay, material properties. Okay, yang bawah ni sama graf, sama bentuk dia, tapi this is called as force displacement. Force displacement. Force displacement. This is force displacement properties. Force displacement properties. Sini juga yield point. Okay, sini juga ada gradient. Okay, sini ada gradient. And kecerunan for this force versus displacement ni is K. K kat sini. So from force displacement properties, kita dapat Q is equal to KD. Q is equal to KD. This is stiffness equation. This is stiffness equation. Stiffness equation. Okay? So yang dia mention about force displacement properties ni kat sini. Okay. Kita tengok apa lagi yang dia highlight. Force displacement properties. Force displacement properties. Okay, structure stiffness matrix. Structure stiffness matrix. Unknown displacement. Unknown displacement and forces. Okay, ini three main step. Three main step. Kita kena calculate K. Kita kena calculate K. K ni is in matrix. Structure stiffness matrix. And then kita akan apply force displacement properties. So after we apply the force displacement properties, from that we will solve for unknown displacement. Unknown displacement. And after that we will calculate for forces. Reaction forces and also member forces. Intrust member forces. Okay, tiga step tu. Tiga step yang kita akan buat. Number one, kita akan establish structure stiffness matrix. Then, kita akan apply the stiffness equation and solve for displacement. And after that, kita akan calculate reaction at the support and also member forces by using displacement. Dapat displacement, baru boleh calculate reaction. Dapat displacement, baru boleh calculate member forces. Without displacement, tak boleh calculate forces. So dia kena ikut flow. Start dengan structure stiffness matrix, then displacement, then forces. Okay, so dalam ni ada banyak term-term baru. Kita tanya dia tentang what is force displacement properties. Okay, refer to the same image. Explain force displacement properties. Okay, kita nak tengok what is force displacement properties. Okay, refer to relationship between forces acting on structural element and the resulting displacement at its nodes. Okay, dia ada kaitan dengan force and displacement. Memang stiffness equation also this. So using stiffness method, we will solve stiffness equation to get the unknown. These properties are fundamental of stiffness method because they allow the behavior of each element in the structure to be mathematically model. Mathematically model ni maksudnya kita akan solve semua guna matematik. Okay. Force displacement property, kita tengok the definition. What is force displacement properties? Describe how forces applied to an element result in displacement. Kita dapat displacement or deformation at nodes. So remember, using stiffness method, we will determine displacement or deformation at nodes only. Kita tak calculate mid-span displacement, mid-span deflection, tak. Kita hanya akan calculate displacement at nodes. At node A, node B, node C, node 1, node 2, node 3. So displacement kat sini can be translation in X and Y, and also rotation lah for beam and frame. Okay, these properties are mathematically expressed using stiffness matrix for each element. Refer back to yang tadi saya draw, from structure into element. Truss tu adalah structure. Bila nak analyze, kita kena divide into element. So we have to determine or establish K, yang mana we write in matrix form. So K ni kita akan start dengan calculating K for element, which link the nodal forces and nodal displacement. Okay, key component, the forces. Okay, forces ni kat sini dia pakai F. Okay, and then displacement dia pakai U. Change F to Q, F to Q, and U to T. Okay, sebab dia bagi sini F dengan U. So, I want the response in terms of Q and D. Okay, force displacement properties. So, kita dapat kat sini Q is equal to KD. What is Q? Q is forces at node. K is stiffness matrix. D is displacement. Okay, so this is the formula we will use as stiffness equation. So we will use this to solve for displacement. We will use this to solve for forces. Okay, go back to this. Okay, kita nak dia summarize the procedure. The procedure. Okay, so this is the procedure for the stiffness method. For the stiffness method, the procedure, we need to divide structure into element. The same term. Divide structure into element. Maksudnya pisahkan daripada structure menjadi element. Element 1, element 2, element 3. Okay. So each element represent a part of the structure. Identify nodes. Identify nodes at the element endpoint. Satu elemen adalah gabungan dua nodes. Satu elemen adalah gabungan dua nodes. Okay, so dekat setiap node tu nanti kita akan check for degree of freedom. Degree of freedom. Okay, dia ada dua jenis properties dalam structure yang we have to understand, and kita dah buat benda ni dalam flexibility method juga. In flexibility method, kita always apply, kalau for beam and frame, we apply EI. EI tu is the properties. Okay, properties ni come from number 1, material properties. Material properties. Material properties refers to the modulus Young. Modulus Young, and then cross-sectional area. Cross-sectional area. So from the cross-sectional area also kita dapat moment of inertia. But for thrust, it is A lah. Okay, and then we also need to have geometric properties. So this is actually the three factors that can influence the results. Means that these are the three factors that can influence displacement. Displacement berubah, reaction also berubah. Okay, means that tiga faktor ni. Material properties adalah E and A, Young modulus, and also cross-sectional area. Cross-sectional area. And then geometric properties adalah length of the member. So benda ni bukan sahaja saya tunjuk sebab ini akan menjadi part of jawapan dalam soalan-soalan kompleks. dalam soalan-soalan complex question juga ada dalam final exam, yang mana soalan-soalan tu need your justification. So justification question tu dia tak tanya reaction, dia tak tanya reaction directly. So you need to understand about all these properties so that you can elaborate. Normally soalan-soalan kalau complex question you need to huraikan on the relationship, what happened to the result if we change the area, what can we done to reduce displacement. So all the answer actually relate dengan all these properties. Okay, so this time saya introduce yang ni dalam kelas so that you ada idea nanti bila nak buat justification tu. Because sebelum ni bila saya dalam kelas kan, kalau kita just calculate reaction, calculate displacement, bila soalan-soalan yang kena explain why this, why that, student normally tak boleh explain. So that is why this time saya introduce you all this term together with this practice. Kita tengok the relationship all this. Okay, you boleh tanya lagi lah, you boleh tanya lanjut, nanti dia akan bagi more explanation. Okay, so means that properties ni yang akan menentukan the results, the displacement, the forces. Okay, bergantung kepada nilai-nilai ni, nilai E, nilai A, nilai L also. So kalau ubah mana-mana nilai ni, dia akan mengubah nilai displacement. So kita dah boleh agak lah kalau kita reducekan size of the members, what happen. Kalau kita increase size of the member, what happen to the displacement. Okay, kalau length tu, kalau dia pendek, what happen? Kalau length panjang, what happen? So all this is very important for you as future engineer because dia melibatkan decision. Dia jadi bila kita as engineer, kita face dengan problem. Of course, as engineer nanti, kita design semua pakai software. Kita tak buat manual calculation. And then bila kita dapat from software, kita dapat apa? Dapat displacement, dapat forces. Dapat displacement, dapat forces. Displacement, internal forces and reaction are the three output we get from analysis. Where either you calculate it manually or you calculate it using software. These are the three output that we get from software. So the behavior of structure, kita tengok pada displacement. The behavior of structure, kita tengok pada displacement. So and displacement tu, dia punya limit, ada allowable limit. Displacement, contohnya as engineer, kita nak design satu tall building. Bila kita design satu tall building, dia ada standard ataupun code of practice yang mana kita kena check. Okay, bila kita dah buat model, kita dah design. So dalam proses buat model tu, kita akan decide lah dia punya support condition, kita masukkan the material properties, the section properties, the geometric properties kita masukkan, and then kita akan run the model. So bila kita run the model, kita akan tengok the behavior. So behavior tu adalah displacement. So we will look at the displacement and we will compare the displacement with the code of practice. Pada code of practice, dia akan ada allowable limit. Dia ada formula untuk check. Kalau building this height, berapa allowable limit? Kalau interstory, berapa dia punya allowable limit? So biasa berlaku bila kita check using dia simple formula only, dia based on the height of the building. Okay, adalah formula dia. Kita check kan displacement yang kita dapat from kita punya analisis guna software tu exceed the limit, lebih besar daripada allowable limit. So at that time kita as engineer kena buat decision lah. So if this thing occur, so kita as engineer kena buat decision. Apa kita nak buat pada building ni? So kita kena redo. Kita kena tengok balik kita punya building model. Kita kena buat apa? Kita kena decide apa yang kita nak ubah dalam model building kita tu, so that dia akan bagi kita displacement yang lagi rendah. Displacement yang lagi rendah yang mana dia kena below the limit. So at that time, apa yang kita nak ubah? Yang kita nak ubah, possibility yang kita boleh ubah adalah tengok kepada material properties and also geometric properties. Tengok, boleh tak ubah nilai E? Boleh tak ubah cross-sectional area? Ataupun boleh tak ubah geometric properties? Okay, so normally kita akan play with all these properties and then kita akan rerun balik and then kita akan dapat new results, the displacement, then compare again. So this is very important for you to know, for you to understand because bukan hanya belajar calculate ya, belajar calculate displacement, belajar calculate reaction, tapi properties yang bagi effect tu kena tahu juga. Okay, so kat sini kat sini lah dia highlightkan about all these material properties and geometric properties, and yang mana term-term ni dalam software memang ada. Dalam software. Nanti next session saya tunjuk sikit kot. Sebenarnya you akan belajar the software masa you ambil computational analysis. Okay, tapi actually most of the software memang you kena letakkan, kena define the properties. All these properties you kena define. Okay, so step tadi tu, kita divide structure into element. Endpoint adalah nodes. So one element tu ada dua endpoint. Hujung-hujung tu adalah nodes. Lepas tu kita kena faham the properties, the material properties and the geometric properties. And then we will compute the stiffness matrix. Tapi in our case, kita tak tengok for local stiffness matrix, kita go directly to the global coordinate. Kita tak ambil yang local system lah, kita akan refer directly to the global coordinate. Okay, so from global coordinate ada formula, so kita akan establish the global stiffness matrix, the stiffness matrix for the truss, and lepas dah dapat the stiffness matrix for the truss, we will apply boundary condition. So boundary condition is satu lagi term yang ada dalam software. Boundary condition refers to support system. Boundary condition refers to support system. Dia tak pakai term support dalam software, dia pakai term boundary condition. Pin roller fix tu dalam software disebut sebagai boundary condition. So kat sini dia sebut identify support and other constraint. So dia ada term yang mewakili term yang kita pakai for boundary for support. Boundary condition means support. Constraint juga means support. So kalau disebut constraint tu, what is constraint? Constraint refers to support. What is constraint? Constraint refers to support. Sebab constraint means no displacement. Constraint means no movement. No movement merujuk kepada support. No movement merujuk kepada support. Tempat yang ada support, yang ni kena imagine ya. Tempat yang ada support tak ada pergerakan, no movement. This is constraint. Okay, and then kita akan formulate force displacement equation Q is equal to KD, and then from this equation we will solve for displacement, and then we will solve for forces. Okay, so inilah dia apa yang di-explain dalam textbook. Okay, member and node identification. Yang ni kita baca sikit sebelum kita end session malam ni. Member ni elemen dalam buku. Boleh je pakai member sekejap elemen, doesn't matter. It is the same thing. Member and node identification. Node ni join, member ni elemen. Okay, kat sini saya nak highlight. Okay. We will specify each member by a number enclosed within a square and use a number enclosed within a circle to identify nodes. Also, the near and far end of the member must be identified. This will be done using an arrow written along the member, with the head of the arrow directed towards far end. Okay, ini Ya, mana diagram tu? Diagram ni lah. Diagram ni. Okay, this is trust. This is a trust. This is a trust. Tadi dia sebut note dalam circle. Note dalam circle, ini dia. Note number kita tulis in circle, dalam bulatan. Dalam bulatan. Kalau cara lama, kaedah sebelum ni, kita label join as A, B, C. But, sebab kita nak pakai dalam software kita tak boleh pakai A, B, C. Sebab A, B, C tu dia ada limitation. Software ni kita guna untuk analyze complex structure. Yang mana dalam complex structure tu dia maybe ada 1,000 nodes. So, we cannot use A, B, C. Jadi, kita pakai numbering. So, numbering for analysis, for numbering kita akan letak number. For A, B, C tu, for nodes kita akan letak number dalam circle, bulatan. And kalau you tengok kat sini ada lagi number dalam square. Number dalam square ni is referring to element. Element 1, element 2, element 3. Kita tak sebut member AB, but kita sebut element 1. Kita tak sebut member BC, kita sebut element 2. So element dalam stiffness method, element kita labelkan in numbering dalam kotak, dalam square. Bila kita tulis tu, kita tulis dalam square. Nombor dalam kotak tu, dalam square, that is referring to element number, and numbering dalam circle, dalam bulatan tu is referring to nodes. Node number 1, node number 2, node number 1, node number 2, node number 3. Macam ABC lah. Tapi kita tulis in numbering, node number 1, node number 2, node number 3. Okay, 3 nodes. And element, kita tak kata member AB dah. Kita kata element 1 and element 2. Okay, tadi dalam ayat tu lagi, dia sebut arrow, about arrow. Kita kena letak arrow yang parallel dengan member. Kita wajib letak arrow. Dalam soalan nanti, arrow is not given. We have to put arrow. We have to put arrow. So, bila kita draw the free body diagram, kita kena letak arrow pada each member. Letak arrow pada each member. Arrow ni, dua arrow ni. Dua arrow ni represent. Dua arrow ni is needed to identify near and far end condition. So one element ni, satu elemen dia ada far end, dia ada near end. So dia sebut kat sini tadi. Ulang-ulang baca sampai faham. Okay, dia kata member label by number enclosed within square, itu member element. Lepas tu number enclosed within circle, identifying to identify nodes. Okay, lepas tu dia mention about near and far end. Near and far end, yang ni kita determine using the arrow. Okay, yang ni kejap sebelum kita end session malam ni, kita tengok dia explain on this. Okay, and saya ambil yang ni Saya ambil yang diagram tadi. Okay, elaborate. Okay, so okay, from the paragraph and the diagram. Okay, purpose of identification. Identification of member and nodes is essential to create clear reference for calculation and assembling the stiffness matrix mesti label. Jangan risau, first session teori memang pening. Tapi sebenarnya nak buat nanti senang je. Cuma konsep kena clear dulu baru you boleh senang nak buat calculation nanti. Okay, nodes are the key point where forces, displacement and boundary condition are applied. This one refers to yang tadi saya sebut everything. Forces, displacement, merujuk kepada nodes. Kita tak tengok pada tengah-tengah tu. Node tu pada hujung-hujung tu, end point tu. End point. Nodes tu yang end point tu. Tengah-tengah tak kira. So, sebab tu dia kata kat sini nodes are the key point. Where forces kita apply dekat node. Displacement kita apply dekat node. Boundary condition support juga dekat node. Itu makna dia. Members are structural component connecting the nodes. Elemen ni members are structural component connecting the nodes. Okay, kita tengok about node identification. Node identification. Nodes are assigned numbers enclosed in circle in the figure. Nodes. Node 1, node 2, node 3. Node 1, node 2, node 3, dia kata nodes are assigned numbers enclosed in circle in the figure. Each node position specified in global coordinate system. So bila kita guna software, kita pernah guna software kan? So kita kena apply the coordinate system. Dalam software memang akan pakai coordinate system. Bila kita nak masukkan node, kita kena letak coordinate 00, 30, 43. So semua tu coordinate system. Coordinate system. So coordinate system kita pakai XY. Yang ni 2D kita pakai XY. So dia kata kat sini each node position is specified in global coordinate system. So kalau you tengok soalan-soalan past years, you akan jumpa the term in the global coordinate system. In the global coordinate system. Establish the structure stiffness matrix in the global coordinate system. So memang yang ni term yang kita pakai lah. Global coordinate system. XY for easy reference. Example node 1. Okay, node 1, 00. Node 3, node 3, 30. Refer pada yang ni lah. Node 1. Tak, dia bagi contoh je. Okay, yang kita kat sini node 00 kita node 2. Sini node 1, 3, 4. Ini node 3, node 3, 30. 30. So semua ni coordinate system. Coordinate system. Node represent connection point where displacement or forces will be determined. So semua displacement and forces kita akan determine using add nodes. Member identification. Member or element is assigned a unique number juga, enclosed in square in the figure. Yang ni. Element 1, element 2. And in the square. This is for element or members. This numbering allows clear tracking of each member's force displacement properties during the stiffness matrix assembly. Okay, kita kena letak arrow kan tadi? Kita kena letak arrow. Why we need to put arrow? Because we need to identify near and also far end of each member. Kita kena identify. So for one element, dia akan ada 2 end. 2 end. So dua-dua end tu kita sebut sebagai near end and far end. Near end and far end. Near and far. Ataupun IJ. Biasanya near dengan far lah. Dalam appendix ditulis IJ. Samalah near and far makna dia. Okay, which actually we identify using arrow. Arrow ni kita letak ikut suka kita. Kita nak letak arah mana-mana pun tak kisah. Tapi dia mesti parallel. So dalam case ni, contohnya kan, elemen number 1 ni, saya buat dia ke kanan. Kalau you all nak buat dia ke kiri pun boleh. Tapi kena ada arrow. Arrow kena letak parallel dengan member. Sama juga dengan member 2, elemen 2. Elemen 2 ni saya buat dia ke atas kan. Kalau you tak nak buat ke atas, you nak buat dia ke bawah. Ke bawah pun boleh. Okey, cara letak arrow ni mesti parallel tapi arah ikut suka kita. Okey, why arrow is important? Because daripada sinilah kita akan tentukan which node will be the near end, which will be the far end. Far end. Far dengan near tu kita identify from the arrow that we put. Okay, dia kata kat sini the arrow indicates the positive direction of local. So dia tak detailkan pasal arrow ni. Kejap. Dia tak detailkan pasal arrow. So arrow ni dia macam ni. Arrow ni okay, saya buat kat sini. Okay, this is one element. One element. So dia akan ada satu N yang jadi near node, satu lagi N yang akan jadi far node. So macam mana nak identify near and far end node ni from the arrow? Kita letak arrow, means arrow ni is moving towards far end. Dia bergerak ke far end. Moving towards far end. So bila kita letak arrow macam ni, automatic point sini akan jadi far, di belakang dia akan jadi near. So dalam case ni, bila kita letak arrow this direction, so dia moving towards far end, so satu ni akan jadi far, belakang dia ni, yang dua ni akan jadi near. Near and far. Near and far. So this is very important. We need to identify near and far end. Okay, so kita tengok je explanation yang dia bagi ni before we end session. Okay, in the figure, there are 3 nodes. Betul, there are 3 nodes. Node number 1, node number 2 and node number 3. Member, salah. Sebab ChatGPT bukan 100% betul. Member hanya ada 2. There is only 2 members. 1 and 2. Okay, so dekat sini note betul, member ada 2 bukan 3 member. Arrow ni betul, arrow direction, each member has an arrow pointing from near end to far end. Arrow tu pointing from near end to far end. Okay, tengok dia betulkan. Okay, dia dah betulkan dah. Member, so this trust consists of 2 members. 2 members, member 1 connect node number 1 and node number 2. Connect node number 1 and node number 2. Dia label pun salah. Okay. Member number 1 kita connecting node number 2 and node number 3. Okay. Nampak tak? ChatGPT is not 100% correct because sometimes it can give us wrong response. So we have to be the subject matter expert to verify the response. Okay, so kat sini we have element number 1. We put the arrow towards right direction. So 3 will be the far end. 3 will be the far end. 2 will be the near end from the arrow. Sama juga macam element number 2. Element number 2 we put arrow in this direction, means moving towards far end. 1 will be the far end. 2 will be the near end. So why it is important, yang tu saya akan explain in another session. Okay, in another session. So disebabkan minggu depan, minggu holiday, and then lepas tu you all convo. Kan ada yang convo kan? So this week, saya akan buat another 2-hour session. 2-hour session untuk cover minggu you convo. Okay. Bila ada malam-malam yang you free tak? Rabu, Khamis, Jumaat. Untuk kita buat another 2-hour session untuk kita completekan trust analysis. Because you need full solution of trust untuk buat assignment. Boleh tak kita ganti, kita buat extra class 2 hours either Rabu, Khamis or Jumaat. Boleh tak?
Rabu Khamis ada kelas, madam.
Khamis ada kelas. So hari apa yang boleh masuk? Esok esok ada kelas dengan grup. Boleh je online kan? Esok ada kelas dengan grup 5B. Khamis ada kelas dengan 5A. You all nak masuk hari apa? Atau nak buat hari Jumaat malam? You all nak masuk esok boleh, lusa boleh, atau you nak buat your group asing hari Jumaat malam? Which one? But I need your response. You nak esok or lusa?
Saya rasa Jumaat, Doktor.
Jumaat Okey. Kalau macam tu kita set Jumaat Jumaat 2 jam. Kalau 2 jam ikutlah pukul berapa yang you rasa okey kita buat. Boleh je nak start pukul 9 boleh, nak start pukul 10 pun boleh. Tapi kita kena buat juga 2 jam tu sebab lepas cuti you all convo. But I need to cover trust analysis sampai habis lah, sampai habis so that you can proceed with your assignment. Assignment before 6 hari bulan tu lah. Okay, so betul Jumaat Okay, so kita akan onkan 2 jam kelas Jumaat malam. Tapi kalau ada yang nak masuk kelas esok or lusa pun boleh. So kita akan on je mana-mana hari tu. Okay? So don't worry, stiffness method ni topik paling senang Paling senang untuk you dapat full mark. Cuma memang teori dia memang nampak macam banyak sangat. Teori tu sebab nak grab all the concept. You kena ingat structure ni dia satu. Cuma bila kita buat kurikulum, kita kena pisahkan. Kita kena pisahkan dia jadi asing-asing. So that's why you jumpa structure dalam solid, lepas tu determinate structure, dalam static dynamic structure, lepas tu dalam solid, dalam determinate structure, dalam indeterminate structure, design ada lagi. So semua tu is actually one. Tapi kita pisahkan sebab dalam syllabus kita kena ajar satu sikit-sikit lah kan. And memang saya nampak ada student or most of the student dia tak nampak benda ni satu. Dia nampak separate. So kat mana dia punya connection tu yang properties tu. Okay, kita kena nampak dia satu dia satu. So so this time bila ada ChatGPT ni memang you are very grateful. So all misunderstanding ke tak faham ke you just can ask ChatGPT. You just can ask. Tapi kena ingat bila guna ChatGPT you tak boleh just simply put question, receive answer, you just take the answer. Because we need to verify. Sama macam saya tunjuk tadi, step tadi, kita boleh identify kat bila masa dia respon salah, kita tahu kita tahu yang respon pada waktu tu dia bagi respon salah. Okay, sebab dia not 100% betul. Tapi most of the time 90% tu okay lah. Cuma dia akan ada 10% yang salah tu yang kita kena identify. But it's good untuk explain more. So that is why dalam ChatGPT or AI tools ni kita boleh guna dia untuk bantu kita as personal helper, as personal assistant. Tetapi jangan lupa as student kita punya main reference is textbook. Cuma textbook ni dia dah cram kan. Jadi macam baca tak faham. So jadi kita boleh gunakan ChatGPT untuk minta dia elaborate, untuk explain more. Kalau you nak detailkan lagi. Boleh zoom in lagi bila pakai ChatGPT tu. So baca and try to relate. So ada banyak lagi term yang saya tak sempat nak introduce. Okay, dia jadi take a long time sikit sebab kita together dengan yang ni. Dengan ChatGPT. Actually saya from 2 previous session dengan group A dan group B tu saya dah summarize jadi updated version slide yang mana yang tu saya akan tunjuk untuk kelas 2 jam. 2 jam kelas 2 jam hari Jumaat ni lah. Okay, so kelas 2 jam hari Jumaat ni saya akan habiskan explanation about all the terms Lepas tu kita akan buat solution. So the first part of the solution tu kita akan establish the stiffness matrix K, and lepas tu kita akan calculate displacement and also forces. Itu je QKD. Just remember QKD. Yang tu je yang kita akan pakai untuk analyze stiffness structures using stiffness method. Okay, so that's all for this session. Thank you very much. Sorry tadi petang tak sempat nak inform awal. Okay, thank you for joining this session. InsyaAllah kita jumpa hari Jumaat physical. Hari Jumaat pagi physical session. Okay, physical session, kelas bilik seminar as usual dan malam online. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, madam.
Okay.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Terima kasih, madam.
Sama-sama.